I'm Tom Fisher from the University of Minnesota, and I'm going to be the MC and moderator for the next 2 days. And we have an incredibly exciting summit with remarkable speakers. We also really want to engage you as much as possible. So be thinking of questions to ask our speakers, and we'll have plenty of opportunity as they're sitting on the couch here to engage in conversation with all of you. We are going to hear a lot of exciting new information about tools and methods and applications. I thought, though, that I would just start by reminding all of us, but I think what brings us here and why GeoDesign is so important. On the plane out here, I was reading the current issue of Harper's, and there's a piece by Rebecca Solnit at the very beginning in which she makes the argument that we have been essentially at war with nature since World War II. She makes the compelling case that we were on a wartime economy in the Second World War, and after that war, we decided to continue that economy, and we declared war on nature. And her piece is really calling for an end to our war on nature, where, as she said, we go back to the more modest scale of consumption that we had before World War II, to agriculture that uses fewer chemicals and fossil fuels, to more locally sourced goods, and to less corporatized globalization. Instead of thinking about in terms of going back, it may make more sense to say that it is finally time to end the war. And I think GeoDesign is the way in which we will envision a different kind of future from the one that we have been existing in since World War II. A future that we're not declaring war on nature, and one that we can live more sustainably on this planet. The other article of interest in this was by Wendell Berry, the essayist. And he makes the argument that we have been, over the 20th century, confusing parts for wholes, that we've disaggregated the world, taken it apart, and we have forgotten how to put it back together again. And he makes the argument that the health of the context, the body, the community, the ecosystem, would reveal the health of the work. And I think the health of the work of GeoDesign is about that. Seeing the wholes again, seeing how all of the work that we do in our various disciplines, our various industries are connected to larger ecosystems and basically to the whole of the planet. And again, I think GeoDesign, as I think you'll see in the next 2 days, is the way in which we are going to achieve that. So it's an exciting time. I think we've never been in a moment in human history where we've had to envision a future very different from the one that we are currently in. And all of you and everyone involved in this movement, I think, is going to be helping make that happen. There are two introductions I want to make. One is a thank you to the person who's really behind this summit, which is Shannon McIlvaney. Shannon's up in the back there, and he spends months sort of bringing the best possible speakers working on this work from around the world here. And thank you, Shannon, for all of your work. And of course, the other person for whom we are eternally grateful, for whom we wouldn't probably have GeoDesign, probably wouldn't have even GIS, certainly the way we know it, and really the host of our summit is the president of Esri, Jack Dangermond. And so, Jack, I'll turn it over to you.
Thank you. Tom is great, isn't he? I mean, he's been kind of an inspiration and leader in this field. And in this summit, and I appreciate it very much. I'm going to very briefly give you some context, starting off with the notion of why are we here? Well, did you ask yourself the question why you are here? Silently think about it for a moment. For me, it's the purpose of creating notions and relationships and friendships and better understanding of this field that we call geodesign. And we always, at least in the last 5 years, has it been, Tom? Start off by having you introduce yourself to another person, because one of the goals is to create relationships. So Ben, turn around and introduce yourself to somebody behind you and let them do the same thing. And all of you do the same thing, please. One of the objectives is to do exactly what you're doing, which is to create friendships and relationships and a sense of community. And really a community with a kind of common purpose of advancing the methods, advancing the technology behind the methods, advancing the science associated with and all of the above GeoDesign. So this kind of meeting, the kind of discussions that you just did, ought to be happening all the time. And the way that Tom has structured this and Shannon has structured this is to have lots of open dialogue and interaction so that we actually all learn at the level that we're capable of learning fast. The context that Tom laid out is in some ways daunting. Last weekend I spent with Peter Raven, the famous botanist, and Paul Ehrlich. And we talked to the California Native Plants Association. It was a thrilling conference with thousands of people that were interested in, they were all biophiliacs, interested in plants and living things. I have an affinity to them. But Paul Ehrlich got up and he, of course, wrote the Population Bomb book in the 60s, which got people starting to think. He was saying, you know, there's only about a 10% chance that in 100 years from now it's going to go on. Very controversial statement. In other words, humanity. And this was very controversial to this audience, of course. We're all living in it. But he made the case with pretty good science behind it that it won't work. It won't work out. And when Peter got up, he said, you know, Paul, I really disagree. He said, I think it's only about a 1% chance. And I mean, the audience was, and they just argued about this back and forth. So it's that context, which is kind of doom and gloom context, that we are here together to talk about how we create the future rather than being at the effect of the future. And I think geodesign is exactly that. Geography as a science of our world and geodesign as a methodology which employs it are more important than we've ever sensed before. They provide the context and content for making spatial decisions. They provide us the practical means for implementing change. Now, we're not going to, I mean, Paul's point is we need to scale it back to about 2.5 billion, or we can't sustain it. The Earth, we're now consuming about 1.4, 1.5 Earths in resource sustainability. So we can't sort of design our way out of it. We've got to do some other dramatic things. But geodesign is both an old idea, an ancient idea, but it's also a brand new idea supported by emerging and advancing technologies. And we're going to hear today at all different scales, starting with our keynote, Noel Cressy, who is going to look at context and statistics and quantitative methods as they apply to this, to your work, down to micro examples, mini demonstrations of how we can struggle to employ science and support the world and the future using these scientific methods to integrate them into the design processes. I'm always encouraged because I see GIS as now integrating into almost everything we do. And I'm uniquely in a position to do that. In almost everywhere I travel, I see wonderful examples of geographic information deployed to make things more efficient or improve decision making or communicate. It's really very, very, very heartening to me. But we haven't done as much in this linking of geographic science into the design process, and that's what we're here to talk about. This idea that we can actually take geographic knowledge from all the different ologies, as Ian McHarg used to talk about it, and integrate it into the way that we design things, the way that we collaborate on creating the future, to create new visions of cities, smarter cities, more efficient cities, and more beautiful concepts for conserving nature and the ecological infrastructure that sustains us. This is basically the subject of today. Now, I wanted to start the meeting off by talking just a little bit about what's happening with the technology, this notion of GIS. And there are millions of people now that use it. They use it in desktops. They use it increasingly as web services. And third, there's a new pattern emerging, which is kind of like one big GIS in the sky, a kind of web GIS pattern, which unifies distributed services of all types and makes them available in easy and usable forms. This WebGIS architecture, as we like to refer to it, is really based on faster machines, interconnected, the web, cloud services, web services, new standards. And what's happening is that all the servers that measure and manage things are becoming connected to this network. And all desktops which consume that data are streaming data out of it. And new generations of apps which take this community or open data content are starting to emerge in all sorts of forms. Crowdsourcing apps, navigation apps, field data collection apps. In other words, a larger contextual GIS which connects everything else that has been done in this field. It brings together all the data. It brings together all the technology pieces into this like web GIS. And it allows us to integrate in data of all types. Maps and data, streaming data, sensor networks, imagery, even integrate in as web services and web maps, analytics and big data processing, social media, enterprise data. In other words, it's a normalization framework for integration. And GIS is all about integration, you know. So if we can take the whole world's data sets and we can integrate it with a common language, and then organize that common language like a library catalog system through a portal where people can search and find and discover the data that they want, aha. I've handled the problem of all the data. I don't need to say, in order to do geodesign, I need to spend all my budget on collecting the data. Right? So this pattern is going to change the way that we approach science, because instead of spending all the budget or time or the equivalent on data collection, we have it at our fingertips. It's going to change, for those of you in professional practice, the way you do practice, because instead of spending all your budget for a design project and gathering the data, it's at your fingertips. It's like dial tone. That changes the method. Instead of spending all the time and, yeah, you get the idea. So content is becoming rapidly available. And this very conference, we introduced this notion some years ago. Now there are 3 million data sets that are living in the cloud that are freely available and spinning. And it's being added to about 5,000 more a day. It's kind of the phenomena of Facebook but for authoritative source maps, not just flying around like Superman, but I'm talking about the substance of GeoDesign, the fabric behind it. This data, this new format web mapping, allows us to visually overlay these different data sets. That's fun. But also do spatial analytics, combining them dynamically on the fly. Again, this GIS in the sky is different than GIS in the desktop, but it has the same characteristics, visualization and analytics. This is a kind of open platform where anybody can dial in. They can write their own code and be fed from it. They can be sophisticated GIS professionals and use it. But they can also be just knowledge workers, executives, business intelligence people, or just casual users that want to look at maps. They can be developers and pull it in like that. And very easy, very accessible, and supporting the new society that we're moving into. My colleague Suzanne Foss is actually going to show it for a half a dozen minutes in the context of GeoDesign, and she's magnificent. So give her a hand to get her warmed up here, Suzanne.
Thanks very much, Jack. All right, so what we're going to look at first is GeoPlanner, which is a web GIS application that's specifically geared for geodesign. We're going to use it to do analysis and see how that can guide land use planning in Sonoma County. Now, as the wine industry is very important in Sonoma, let's say that the county wanted to identify potential land to expand vineyard zoning. So where is there land suitable for growing grapes? GeoPlanner gives you access to a myriad of landscape layers to ask these kinds of questions. This is part of the living atlas that Jack was talking about. This modeling pane allows you to pick and choose from these different layers. So we've selected some parameters for vineyards, things like elevation, slope, land cover, sun angle, and then also areas to avoid, like critical habitat. Now for any data set, you set which values are good or bad for the analysis. So for example, eastern and western exposures are preferred over southern, which actually can give grapes too much sun. And you can also weight the different variables in your analysis against each other. When you run one of these models, the data sets are processed on the fly into a suitability map, and the analysis is recalculated dynamically as you pan and zoom around the map. Now in this case, the darker the green, the better the land for growing grapes, whereas orange and red areas mean that the land's not suitable. And you can easily refine the analysis as you work within the application. Let's say we wanted to consider forested areas. We can make those changes, rerun the model, and immediately see how that impacts the results of our suitability.
Then keep in mind that Suzanne has no local software. This is all running from the cloud. She actually has no local data, although she could complement what she's doing with local data. It just takes a second to have this kick in, that this is a SaaS software as a service, cloud as a service, and she's integrated a half a dozen little data sets that happen to be out there. That's the starting point.
Exactly, thanks Jack. And with these models, with these cloud-based services, you can also weight the different variables against each other. So here we're actually emphasizing elevation, land cover, and slope. So this is dynamic analytic processing in a web GIS, as Jack was saying. Now our final model here shows a lot of potential land for viticulture. But if we want to expand zoning, we need to know where the vineyards already are. GeoPlanner is integrated with ArcGIS Online, the rest of this web GIS framework, so you can easily search for more content from the cloud. So in this case, I'm adding in a layer of existing vineyards in Sonoma, which are shown in gray. And we may also want to consider unavailable land. So we're also going to bring in information on government, residential development, state parks, and other properties where we couldn't convert zoning. So now we're actually ready to use this information to optimize any zoning proposals. This area west of Santa Rosa has both available and suitable land. And GeoPlanner includes tools for creating and designing plans. So I'm going to use these to quickly sketch some proposed zoning in this area. Or sorry, some proposed cropland, I should say. Now as I sketch, what I'm doing is using the analysis as a guide. I'm capturing the areas that are in the darkest green. High suitability in the analysis meant that the land had good characteristics for growing grapes. So things like the right types of land cover, lower elevations, the right sun angles, and so forth. So we're applying geodesign principles by sketching against all those variables at the same time. And we can go even further and evaluate the plans as we make them. This dashboard shows the amount of land proposed for different uses. Now if I click on cropland, GeoPlanner actually summarizes the suitability under those areas. So the colors in the second chart match that vineyard analysis. The darker the green, the better the land. So by the amount of green in this chart, we can begin to evaluate if we're proposing zoning changes in the best areas for viticulture. However, in any community, it's really important, of course, to balance economics and the environment. And when we turn off some of these layers, what we see in the base map is that there's a stream running right through the proposed cropland, and we want to minimize agricultural runoff to riparian zones. One of the other things GeoPlanner allows you to do is work with multiple scenarios. So what I'm doing now is bringing in an alternative plan on the right-hand side, and this one actually accounts for that riparian area. It establishes a conservation corridor around it and adjusts the new vineyard zoning plans. So with GeoPlanner, you can really compare and contrast these different kinds of planning approaches and begin to enable better geodesign by balancing economic and ecological priorities. Now what we're going to do next is switch gears slightly and show how ArcGIS Pro can support urban design. Pro is a desktop application whose usability and performance really make GIS design easier than ever before. It has a ribbon-based interface that gives you quick access to tools like changing base maps, adding data, or zooming to different bookmarks. Pro also delivers amazing speed. It takes advantage of your GPU so that it can boost performance and allow you to really rapidly roam and explore your maps. You can work in 2D and 3D using this particular application. So we'll go ahead and bring in a 2D view of the Francis Ford Coppola winery. And you can even link your views so that you can see multiple perspectives of the same location. The application also helps you be more productive because it doesn't really make you wait. The UI stays responsive even if a map is drawing because it's a 64-bit multi-threaded application. So now we're going to dig a little deeper and see how the app supports urban design. Using Pro, you can actually bring your data to life in 3D. So what I'm doing now is bringing in some traditional 2D building footprints over the town of Sonoma. With Pro, you can transform data like this into 3D using a rule package or a 3D symbol that uses data properties to render features. So this 3D symbol applies wireframes, excuse me, and then renders buildings based on properties like height, number of floors, and usage type like residential or commercial usage. And there's a lot of different properties that you can control with rule packages, things like roof design, roof color, and things of that nature. And it builds a quick 3D scene for us in just a few seconds. And these aren't the only way to create 3D features. With preset layers, you get a gallery of pre-authored common types of layers that help you make great-looking scenes really quickly. What we're going to do here is add some trees over Sonoma. These preset layers also use data properties to render, so in this case, tree species and tree height. And going forward, we'll provide a variety of other preset layers to this gallery. So this is an entirely new way to do 3D authoring. And Pro also supports 2D, 3D editing. So let's say we have a newly constructed building west of the plaza. You can collect features in either mode. So what I'm going to do is collect the new building in the 2D map using imagery. Tools in Pro like analysis and editing are organized into tabs, and you don't have to start any kind of an edit session. You can simply begin creating features directly in your map. And as you finish the sketch, it'll render automatically in any views that have the data. So we'll see that building automatically render in the 3D view based on the rule. And if I update the attributes of the feature, you get that feedback in 3D on the fly. So here I'm updating the height of the building, updating the number of floors to 2. And we'll see the 3D symbol dynamically update the representation of this building. Probably easier to see if I pivot the map a little bit. So this is real-time 3D QA/QC. And if you're used to doing your design work in other types of programs, you can bring those models right into Pro. Pro supports models that are built in Rhino, 3ds Max, SketchUp, and City Engine. So this is a shopping center multi-patch built with additional information on the facade, columns, sidewalk, and other kinds of details. But you also don't have to design every building manually in order to create realistic features. What I'm doing now is actually swapping my 3D symbol from wireframes to a 3D symbol that uses textures. So this symbol, as I zoom back out to the city, this symbol applies California-style textures to each of the buildings. It's also going to be using properties like height and usage type of the building. But in this case, it's actually creating a realistic-looking town scene over all the rest of that data within just a few seconds. So here are those buildings coming in now with the additional textures. So with these tools, Pro really gives you exciting opportunities to render designs in 3D environments. Thanks very much. Jack?
Yeah, that's good. When I was watching that, I was thinking about what Carl said last night, what he did in the 60s. He did the same thing, except the graphics weren't as nice, and it wasn't fast, and it was like by hand. So in some ways, the theory of what we're doing goes back hundreds of years, sketching, evaluating, making decisions. We're simply modernizing it with more tools and more tech. Here at Esri, we have about 700 people that are across the way here. Some of you know them, some of you will visit them, who develop software every year. They make advances basically to their base, just like advances are made between the 60s and the Harvard lab and today. They every year spend resources to try to keep advancing the methods. And this conference is really very valuable because you have a voice to drive some of that work as well. They're working in a couple of themes that I'll just hit on. One of them is more advanced analytics, geostatistical analytics, space-time pattern analysis, 3D analytics, flows, bringing in better modeling tools in the desktop environment. But also online, we're reinventing some of the same algorithms to work dynamically across the web so that we can have cloud-based systems to support GeoDesign. We're making advancements in 3D, as Suzanne showed, but all kinds of 3D. The speed that you saw this rendering in is equal to what you see with a kind of Google visualization environment. In fact, it's so strong. Google has selected it, this platform, our platform, as the foundation for replacing all of their on-premise Google Enterprise licenses. So we're going to be rolling that out in the next few weeks. The GeoDesign is another active research project that is progressing. I think both in the landscape design world like Geo Planner and the urban design world with City Engine and Pro, we're seeing the fundamental methodology that Carl invented almost 50 years ago of data analytics, sketching, evaluation, decisions, be supported in shipping and volume kind of technology. For me, what this means is bringing the design process to people in the GIS field. That means affecting millions of people who are working with this technology. The gap is them understanding design, right? I mean, you guys, many of you are designers. They are not. So the technicalizing of GIS so that it enables this kind of thinking is one aspect. The other aspect is getting the knowledge base and the training and the understanding for being able to approach these kinds of methods in volume. Other work that we're doing is supporting with Geo the app revolution. This is going on. They're now saying 5 devices per every human being on the planet by 2020. This is like 50 billion devices we're going to be mechanically enabled. That's not a joke. This app revolution means we can drive, particularly with cloud services, Geo into, you already have 5 devices, is that what I heard you say? I say 4, okay. Well, so we're living in the future already. This notion of having apps that are accessible to everyone with the power of geographic knowledge, I think will actually, and GeoDesign will actually transform everything. So these are a few that we've been working on. Data collector apps, like we're using for Ebola in West Africa right now. They're collecting observational data. It's going to the cloud. Other people in Geneva are seeing the patterns, trying to understand the statistics of it, and then using geographic approaches to try to stop Ebola. That's an example. Dashboards are giving evaluation pictures about the real-time GIS data that's coming in. Open data is allowing people to share their data openly. Web templates are making it easy for people to build GIS applications very rapidly and more. Suzanne again showed this notion of a 21st century desktop. Steve Jobs, when asked about, is desktop going away, said before he died, no, the desktop is like the pickup truck versus the Ferrari. You've got some people who want to have a Ferrari, but the pickup truck, is a useful thing. So the desktop you saw is being modernized and brought into a new pattern. It's both a web app and also a desktop app with very, very high performance capabilities in the analytics and visualization area. Well, these are just a little glimpse. You're going to be seeing some more from us, but we'll also be seeing lots from you during the week about methods, tools, and advances that you're making. I'll simply conclude with this, as Brand Farron said a couple years ago, we have to get conscious, considering what Paul and Peter said, that we've got to get it together if we're going to have a future. So it's about time to think about that. And you particularly in this room, you who are designers and planners, I think are special people because you're not only evolving with technical knowledge, the methods, but you also have a sense of what design really means. I think it means equipping all of our respective colleagues in the various fields that you come from to kind of get this new method, to use the billions and billions of dollars now of information that's online and available, to understand and embrace these new technologies that can actually let us look and evaluate the future carefully. So I think GeoDesign is a kind of essential foundation for creating the future that's sustainable. Let me leave it at that.